Okay, so now that you've gotten a little bit of background into what the formal definition of the derivative is, we're going to go ahead and move on with an example, right? So here we have a function which is f of x equals x squared minus 4, all right? And so we want to find the slope of the tangent of this function at x equals 2. Okay, and so we're given this point, x equals 2. All right, and so what is the slope of the tangent of my function? It is nothing but, we're saying that we want the instantaneous rate of change of our function at x equals 2. Okay, and so what are we going to do? We're going to go ahead and rewrite our formal definition of the derivative, right? So we said that derivative of f of x is going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and so we need to evaluate what our function f of x is when you input x plus h. So we're going to go ahead and say, well, f of x plus h, I'm going to substitute it into my original function. So that's going to be x plus h squared minus 4. Okay? And so when you simplify, this is going to give you, expand, sorry. Here, this is going to give you x squared plus 2xh plus h squared minus 4. All right? Okay, so now we're going to use this function, f of x plus h, and put it into our slope formula. Okay, so we're going to rewrite limit as h approaches 0 of x squared plus 2xh plus h squared minus 4 minus the original function, which was going to be x squared minus 4, okay, over this, this whole thing is going to be over h. All right, so we're going to go ahead and rewrite it just to make our lives easier. I'm going to say, okay, the limit as h approaches 0. And don't worry about the volume of stuff that we're writing. This is the formal definition of the derivative, and it takes a lot of work, okay? And we're not using any shortcuts. We haven't gone to derivative rules. We're still using the idea of the derivative as the instantaneous rate of change or slope. Okay, so let's keep going. We're going to say that this is x squared plus 2xh plus h squared minus 4 minus, distribute that negative outside the parentheses, and it's going to give you minus x squared plus 4, okay, over h. And so now we need to look at things that are going to cancel out. So let me grab another color, and let's grab this yellow here. Okay, so I have a negative x squared and a x squared at here at the front, so I'm going to eliminate that. I have a negative 4, so I'm going to eliminate this 2 4s, that negative and that positive. And I end up with this simplified expression. Okay, so this is going to be the limit as h approaches 0, okay, of 2xh plus h squared over h. Okay, and so now I can simplify this further because I can write this as the limit as h approaches 0 of 2x plus h. Okay, so the h's here, one of them went out here, and this coefficient went out. So that's how I got 2x plus h. All right, so now we're saying, okay, what happens as h approaches 0? this is going to tend to 2 of x. All we did is we substitute 0 for h and we got 2x. Okay? So we're going to say now that the derivative is going to be 2x. Okay? And this derivative right here, let me highlight it with a green. Okay? That derivative is going to be the instantaneous rate of change. I'm going to abbreviate it with RC, instantaneous rate of change, or tangent. Okay, and so what is that? The slope of the tangent at 2? Simply we evaluate the derivative at 2, and we're going to get 4. Okay, so I'm going to work out another problem using the formal definition of the derivative. So let's go ahead and put that into practice. Now this video is slightly longer than other videos, but it is very rewarding in our discussion. So we're actually going to be practicing how to take the derivative of polynomials for a while. So don't trip. We're gonna get enough practice. Okay. So now we're saying in this example we say we need to compute the derivative and the function right here is going to be given by this. Okay, and so it doesn't really tell us at what point we want to find the derivative. So we're going to say that we want to find the derivative at 2. Okay, all right. So let's write our handy dandy definition of the derivative. So it's going to be the limit as h approaches 0 of f of x plus h minus f of x over h, okay? And this whole thing is the derivative of my function, okay? It's just the equation of the slope. All right. So now we say, okay, well, I know what f of x is, but I do not know what f of x plus h is. So let's put that in. F of x plus h is going to be negative 16, and this is going to be x squared plus 2xh plus h squared, okay, plus 96x plus h. Alright, okay, let me write that again because that might not be that clear. So this is going to be 96, and I'm substituting x plus h, right, for every x. Okay, so now this is what is going to happen. I'm going to distribute that negative 16, and I'm going to get negative 16x squared minus 32xh minus 16h squared plus 96x plus 96h. Okay, so now I know what f of x plus h is. Okay. Alright, so knowing this, I'm going to go ahead and plug it into my formal definition of the derivative. So this is going to be the limit as h approaches 0 of this huge expression right here. So it's going to be negative 16 x squared minus 32xh minus 16 h squared plus 96x plus 96h, okay, minus my original function. So my original function was going to be 16x squared plus 96x, okay, and all of this is going to be over h. Okay, so now we're going to say, okay, well, this is the limit as h approaches 0 of, we're going to look at the things that are going to cancel out. Okay, so let's cancel out some terms. This and hold on, this was a negative right here. So that negative 16x squared and this negative 16x squared are going to cancel out. This 96x is going to cancel out with this 96x. And so eventually you're going to get to this. You're going to write this, negative 32xh minus 16h squared plus 96h over h. So when you simplify and you eliminate the terms that have to be eliminated, and so now you'll see that the h is going to basically go away in some of these terms. Okay, so this is going to be the limit as h approaches 0 of negative 32x minus 16h plus 96. Okay, and so what is the limit as h approaches 0? All we do is we substitute 0 into our expression, and we say that now the derivative of my function is going to be negative 32x plus 96. The negative 16h went away because if I substitute 0 into that expression, I'm going to get 0. Okay, and so now what is the derivative of my function at 2? I'm going to get negative 64 plus 96. That is going to give me 32. Okay, so the derivative of my function is 32. The slope of my function at 2 is 32. And the instantaneous rate of change of my function at 2 is 32. Okay, now this video is slightly longer, so I would recommend to watch it in parts. First, watch all the way up until the first example and then finish it with the last example, okay? So I know that this is going to be difficult for some of you, but everything comes with practice, and I expect all of you to get 100 and ask me questions, send me private messages on Google Classroom, and I hope to see you next time.